The universe is vast, mysterious, and full of secrets that we've only just begun to unravel. For decades, we've thought we understood the origins of the universe, that we knew how it all began with a single explosive event, the Big Bang. For 13.8 billion years, this model has been the best explanation for everything we see around us today. But what if it's not the whole story? What if the Big Bang wasn't the beginning of everything, but just one chapter in an even bigger cosmic story? What if the universe we live in is just one of countless others, merging and interacting in ways we can barely comprehend? It may sound like science fiction, but recent discoveries have forced us to rethink some of our most fundamental assumptions about the cosmos. And perhaps most amazingly, data from the James Webb Space Telescope is fueling a theory so bold, so transformative, that it challenges everything we thought we knew. Before we dive into this groundbreaking idea, let's rewind the clock back to where it all began. Or at least, where we thought it began. The Big Bang, a universe born from nothing. The Big Bang theory has long been the cornerstone of cosmology. It paints a picture of a universe born from a singularity, a point so unimaginably dense and hot that space, time, and matter were compressed into an infinitely small speck. Then, in an instant, the spot expanded to create everything we know today. At first glance, this may seem simple, but when you really start to think about it, profound questions arise. How could everything, all of space, time, and matter, come out of nothing? What caused this sudden explosion of energy and matter? Was there something before the Big Bang, or did the concept of before not exist? The physicist Stephen Hawking once famously remarked that asking what came before the Big Bang is like asking what's north of the North Pole. It's a nonsensical question, because time itself began with the Big Bang. In this view, the universe came out of nothing, and there was no before to speak of. But not everyone agrees. In fact, some researchers believe that the Big Bang wasn't the ultimate beginning. They argue that it was merely a transition, one of countless Big Bangs that occurred in an endless, eternal sequence of universes. This perspective opens the door to a fascinating and complex idea: the concept of a multiverse. The multiverse theory suggests that our universe is not the only one. Instead, it's just one bubble in an endless ocean of universes, each with its own laws of physics, matter, and time. Some of these universes may be strikingly similar to ours, while others may be incomprehensibly different. And according to this theory, Big Bangs aren't singular, unique events. They happen repeatedly, in different regions of this larger multiverse. Our universe could have been born from the collapse of an earlier one, or from a collision between universes. In this view, the Big Bang isn't the beginning of everything. It's just one event in a much larger cosmic cycle. But is there any evidence to support this mind-boggling idea? Could it really be true that our universe is interacting with others? Until recently, these questions were speculative at best. But with advances in technology and telescopes like the James Webb Space Telescope, we may be getting closer to real answers. The James Webb Space Telescope's breakthrough discovery. Launching in 2021, the James Webb Space Telescope is designed to peer deeper into space and further back in time than ever before. One of its primary goals is to study the earliest galaxies and stars, giving us unprecedented insight into the origins of the universe. But beyond this mission, it's also revealing new details about the expansion of the universe that have astounded scientists. You see, astronomers have known for almost a century that the universe is expanding. This discovery was first made in the 1920s, when researchers observed that distant galaxies were moving away from us. The further away a galaxy is, the faster it appears to be receding, a phenomenon known as Hubble's law. But the deeper scientists have looked into the expansion of the universe, the stranger things have become. Over the past few decades, it's been discovered that the universe is not only expanding, but that it's expanding at an accelerating rate. This discovery shook the foundations of cosmology because it implied that something Some invisible force was driving this acceleration. Scientists have dubbed this mysterious force dark energy, and it is thought to account for about 70% of the total energy of the universe. But despite its name, we know almost nothing about it. Dark energy remains one of the biggest mysteries in modern physics. But what if dark energy isn't the cause of the universe's expansion? What if something more profound is at work? One of the biggest challenges in modern cosmology is what is known as the Hubble constant discrepancy. The Hubble constant is the rate at which the universe is expanding. But here's the rub. Depending on how we measure it, we get two different answers. If we measure the expansion rate using the cosmic microwave background, the afterglow of the Big Bang, we get one value, 67 kilometers per second per megaparsec. But if we measure it using supernovae, red giants and variable stars known as Cepheids, we get a different value, 73 kilometers per second per megaparsec. This discrepancy has puzzled scientists for years, and no one has been able to explain why these two measurements don't match. Is it an error in our instruments, or is there something more fundamental that we've overlooked? To solve this puzzle, researchers turned to the James Webb Space Telescope. The telescope recently observed 320 Cepheid stars to get a more accurate measurement of the expansion of the universe. The result? The discrepancy is real. It's not a mistake. It's happening. But what could be causing this difference in the expansion rate? This is where things get even more fascinating. A new theory: merging universes. In December 2023, a groundbreaking study was published in the Journal of Cosmology and Astroparticle Physics, proposing a bold new theory. It suggests that what we perceive as the accelerating expansion of the universe may not be driven by dark energy at all. Instead, the universe's strange behavior could be the result of something far more extraordinary. Our universe could be merging with others. That's right. According to this new theory, our universe is currently interacting with other universes in the multiverse, and these cosmic interactions may be the real reason for the accelerated expansion of the universe. In fact, the study suggests that our universe has been doing this for billions of years, merging with and absorbing larger parent universes. If true, this theory would completely reshape our understanding of cosmology. The expansion we see may not be the universe growing in isolation, but rather the result of the universe increasing in volume as it merges with other baby universes in the multiverse. The idea is astonishing, but it's not just speculation. The researchers behind the study developed a mathematical model to simulate what would happen if several universes were to interact with each other. According to their calculations, these universe mergers would cause the kind of increase in volume that matches what we observe as the expansion of the universe. But that's not all. The model also predicts the rate at which the universe should expand if these mergers take place. And surprisingly, the predicted rate is even better than the traditional Big Bang model. What does this mean for our understanding of the universe? If this theory is correct, it would mean that the universe we live in is not a single entity. It's part of a much larger, interconnected system of universes, each influencing the others in ways we've only just begun to understand. This could explain some of the deepest mysteries of modern cosmology. Why the universe seems to be expanding faster than expected, why we see discrepancies in the Hubble constant, and even the nature of dark energy. But how can we prove the theory? Unfortunately, direct detection of other universes is probably impossible with our current technology. However, there may be indirect ways of finding evidence. Researchers are now focusing on studying the cosmic microwave background radiation that's been traveling through space since shortly after the Big Bang. If universe mergers are real, they may leave subtle imprints on this ancient radiation, providing clues that could one day confirm the existence of the multiverse. A new era in space exploration. We are living in an extraordinary time for space exploration and cosmology. Telescopes like James Webb are allowing us to peer deeper into the cosmos than ever before. unlocking new mysteries and challenging our most deeply held beliefs about the universe. What we once thought was a simple story, a universe born out of nothing in a single explosive event, is turning out to be far more complex and awe-inspiring than we ever imagined. The idea that our universe is just one of many, that it's merging with others in a vast multiverse, opens up entirely new ways of thinking about the cosmos and our place in it. We may not have all the answers yet, but one thing is certain. The more we explore, the more incredible our universe becomes. And who knows, tomorrow's discoveries may be even more astonishing than those we've made today.